Hello, today we're going to learn about microactivity. We're going to learn to plot microactivity graph. Now, this lesson is slightly different from the previous lesson. Instead of guiding you step by step, I will give you opportunity to try to plot the graph on your own section by section. If you see this sign paused, try it. I would like you to pause the video and try it on your own. Once you are done, I would like you to play the video again and check your answer accordingly. If you are ready, we shall start. Let's look at the question carefully. A student investigated how temperature affected the rate at which enzyme digested starch. Enzyme is a chemical that increases the speed of microbial activity, meaning it helps the microbes to react faster in the food. It can be starch, fats, or proteins. Enzyme helps the microbes to break down starch, fats, or protein at a faster rate. Here's the results of the rate of reactions versus the temperature. Now, I'd like you to turn over to the next page. You will see an empty graph without the points on each axis. I would like you to pause the video at this point and refer to the results and plot the y and the x-axis accordingly. Now pause the video now. Alright, you may have finished plotting the axis. Let's check our answer. To distribute and to make full use of the entire graph, this is what I've done. For x-axis, the temperatures varies from 0 to 60. I have 1, 2, 3, 4, 5, 6 big boxes, meaning I can actually divide the temperature into 10 degrees Celsius for each big box. Therefore, I have 10, 20, 30, 40, 50, all the way to 60 here. For the rate of reactions for the y-axis, I need to plot from 0 to a maximum of 138. Therefore, I divide my y-axis accordingly to 20 rate of reaction per minute for every 10 units. Therefore, I have 20, 40, 60, 80, 100, 120, and 140 here. With that, I'm making full use of the entire graph. Next, I'd like you to pause again and start plotting the points. Pause the video now and plot your points accordingly. Alright, have you finished plotting the points? Now, if you have finished plotting the points, these are how your points should look like. Next, what we're going to do is draw the curve. Remember, I mentioned, before you draw the curve, use your finger to go through the points. And in order to draw a smooth curve, you may like to you would like to connect to the 3 points first and pause for a while before you connect to the next point. Now, I would like to try to connect the first 3 points here. And I pause. Next, I realized that this point is a bit out of position when I try to connect the curve from here to here. So do I connect this point in order to come here? I don't think so, because microbial activity graph is a smooth curve. So what I'm going to do is I'm going to skip this point, which most probably is an error, and continue to the next point. If I realize that your curve is a bit out, so what you can do is erase it and try to connect it again. And I continue to my next 2 points to ensure that my curve is smooth. I'll use my finger to go along the curve in order to have a sensing on how the curve should look like. And that's the peak, and that's where the curve decreases. And here you are. That's my completed curve. Now, once you have completed, I would like you to turn over to the questions. Let us do the questions step by step. In the experiment, which temperature, not 40 degrees, does the rate of reaction appear to be incorrect? I would like you to pause at this point of time and look for the answer. Remember to indicate question A on your graph paper as required. Pause the video now and write down your answer. Alright, have you done question A? Let us check our answer. Remember, we mentioned that this point may be out of point because it doesn't fall within the smooth curve. Make it a habit. Circle it and indicate the question number. Draw a dotted line to show your answer. That way, you will help the examiner to check your answer accordingly and award 1 mark to your correct answer. Finally, write down your answer on the question paper, and the answer is 15 degrees Celsius. Next question. Use the graph to find the rates of reaction. Now pause the video now and go back to the graph and indicate your answer. Alright, is your answer completed? Now part B. Find the rate of reaction at 50 degrees Celsius. Again, at 50 degrees Celsius, draw your dotted line and hit the graph. Once you hit a graph, draw a horizontal dotted line to indicate your answer. Again, remember to write down your question number to represent your answer. Therefore, your answer here is rate of reaction 110 per minute at 50 degrees Celsius. Next question. What is optimum temperature for the enzyme? Meaning, optimum means the best temperature for the enzyme to have the highest rate of reaction. You may like to write this down to remind yourself. Again, pause the video and indicate your answer on the graph. You ready? Now, let's look at the graph. Here's my answer. Optimum temperature the temperature that is the highest. No, sorry, I repeat myself. Optimum temperature, meaning the temperature where I have the highest rate of reaction. This is the highest point. It is also the highest rate of reaction per minute. What is the temperature? The temperature is at 35 degrees Celsius. Again, I draw a dotted line to indicate my answer is this with my question number, part C. Therefore, my answer would be 35 degrees Celsius. Now, let's look at question D. What happens to the rate of reaction once the temperature goes beyond the optimum temperature for the enzyme? There's a mistake here. I should type temperature for the enzyme. Now, I will help you with this question. Looking at the graph, the question asks, what will happen to the rate of reaction once it goes beyond, after the optimum temperature? What happens to the rate of reaction after it has gone beyond or after the optimum temperature? It comes down, meaning the rate of reaction decreases. So how do we answer the question? The answer would be the rate of reaction decreases once the temperature goes beyond the optimum temperature for the enzyme. Now let us look at the class question. Name 4 factors that affect the microbial activity. Meaning, what are the 4 physical factors that will affect how fast or slow microbes work on food? I'll let you to pause the video a while. Think of the answer. Write down your answer before you check for the answer. Alright, welcome back. Did you manage to find out the answer? Now, if you refer to the textbook, on this page, page 106, the section What are the ways to prevent food spoilage, you were able to find the answer. Now, we have learned that microbial activities can cause food spoilage. The microbes is in the air, it's everywhere. But how do we reduce microbial activities? There are 4 factors we need to consider: the temperature, the water content, pH level, and oxygen supply. For instance, I have a packet of bananas here with the plastic open and it's exposed to the air. In the air, there is moisture in the air and plenty of oxygen in the air. With that, my bananas will turn bad very quickly. As you can see, there are already blood stains on the banana, and the banana is not fresh anymore. That is caused by microbial activity. Now, how do I prevent that my banana will spoil further? What can I do? Here I am. I have this Ziploc. What can I do? What I can do is place the banana into my Ziploc. Before I zip it up, I will squeeze out all the excess of air in the ziplock and before I zip it up. With that, the banana is in an environment that has lesser moisture in the air and lesser oxygen supply. Last but not least, I'll keep this banana in a cooler place, and that will reduce the microbial activity happening on the banana, and I can store and keep the banana for a longer period. Back to the question. Name 4 factors that affect the microbial activity. Therefore, the answer would be pH level, water content, temperature, and oxygen supply. There you are. I have completed my questions. Hope that you have done the task very well. All the best to you to the coming test and examination. Goodbye.